Good morning, everyone. My name is Huiyuan. I'm a UX designer working at Ontario Telemedicine Network in Toronto, Canada. So this work was done with Aisha, Bonnie, and Derek between 2013 and 2015 when I was a graduate student in the GEM lab of Dalhousie University, Canada. So many of you may come to Denver for the first time just like me. Being a stranger in a new city, you might wonder, what's there in the neighborhood? Any local restaurants or bars? Any services such as grocery stores or banks nearby? Or any attractions such as art galleries, museums, or parks? So to not only get familiar with the physical space, but also build an appreciation of the neighborhood as place, you might want to pick a number of interesting locations, plan an itinerary, and walk around to explore a bit, and get a sense of where and how far things are and in relation to each other. So the high-level question we ask is, how might mobile applications be designed to support such activities? So one of the existing tools that pops in your mind might be mobile wayfinding apps such as Google Maps. So Google Maps is great for just-in-time queries that helps you navigate from A to B. However, with two comparative field experiments, we demonstrate how alternative approaches, more specifically, how synchronized spatial views providing compatible details with easy switching between them could help you remember the neighborhood better and improve the efficiency. So this would benefit new residents such as students, professionals, tourists, or others like home buyers, renters, or even yourself, who wish not only to discover an unfamiliar neighborhood in the city, but also to know its layout. So our work focuses on goal-driven expeditions of urban walkable neighborhood. For example, to explore amenities nearby a potential home. So we define a neighborhood expedition as exploration with a purpose in mind. And it involving both planning and serendipitous encounters in situ. So our approach is like this. First, we conducted a field assessment of Google Maps with a home buying scenario to assess its usefulness in supporting neighborhood expedition. We then designed a prototype application called Block Party that addresses a number of limitations of Google Maps, and then evaluated it in a second replica field study. So the Google Maps field study was run in Harbor City, Halifax, with 10 participants, each taking 2.5 hours. So the scenario was, imagine you are looking to purchase a home and you have identified two, and you wanted to explore the neighborhood each home is located in. So one is a more familiar neighborhood in the waterfront, the other is a less familiar downtown Dartmouth neighborhood. So this selection was to explore the potential impact of prior knowledge of the neighborhood. So participants completed a set of tasks with the Google Map views that they preferred, including a top-down 2D map, a map with a route, satellite or text-based navigation views, or street view. So they were free to change views as desired. So the study tasks are designed to simulate the experience of neighborhood expedition, including searching for a set of places or service categories such as restaurants, build a multi-point itinerary, walk to each one in the route, or periodically noting where and how far the key landmarks are, and star the locations they're interested in on the map, and change itinerary midway or at new point of interests. So the pre-study demographics data and self-reported sense of direction questionnaire was conducted. A post-study neighborhood spatial knowledge test was conducted, and the video and screen capture data was synchronized and coded, and the coded video, interview, and notes were grouped thematically with the affinity diagramming process. So we found that Google Maps assumed a sequential and point-to-point workflow. So participants begin with the target identification on the map and followed with a route, and sometimes followed by navigation and street view display at the end of destination. However, if the participants wanted to use the views in a different order, they required 1 to 5 redundant clicks to reach the view they desired. So this was cumbersome. And 3 people closed the application 1 or more times to break out of an unwanted state. Moreover, selecting views for other activities during navigation, such as determining a relative direction of a landmark or star location on the map, will usually be impeded by the design. Second, 3 out of 10 people use the street view as a strategy for reorienting or locating target destinations. But when it showed multiple buildings or outdated images, it was found unhelpful. Finally, the multi-point itinerary support was minimal in Google Maps. However, we do note that in more recent versions of Google Maps, they do have better support for multi-point itinerary. So we designed a mobile app called Block Party to address those limitations. For audiences who are not familiar with the term, Block Party means a street party for people living in a neighborhood or a city block, which usually generates a positive sense of community. So Block Party supports 3 distinct views and 2 modes. So users could select point of interest from potential locations and plan an order for visiting each of them. Block Party supports easy and non-linear switching and synchronized data or operations between these views. Also, the immersion view has an augmented reality view with camera stream and display the names, address, distance kind of information of a point of interest from an egocentric perspective to support the sense of orientation. And also, the separation of the select mode and plan and go mode allow for checking or adding new locations without losing the existing itinerary. In addition, Block Party has a curated directory-based list of point of interests and annotation feature to further support neighborhood expedition. So what makes Block Party different? First, Block Party addresses a gap in the current mobile wayfinding apps in their use for neighborhood expedition. And also, most of the research has compared different spatial views rather than explore how they can work together to support an activity. So inspired by the coordinated multiple views in visualization, that is, users might understand the data better if they can view it from different representations. We wonder whether synchronized spatial views can help people understand the neighborhood better. So the Block Party was evaluated with an adapted version of the Google Maps study with 10 new participants and again taking 2 to 2.5 hours. So we replicated the study design and analysis methodology, except that a few destinations where users can choose from changed due to business change. And 2 images in the spatial knowledge test were updated due to city renovation. So the demographics were similar, with the average age 26, and the average self-reported sense of direction was also similar. And both groups were more familiar with one neighborhood over another prior to the study. So we look at how participants use different views. We focus at 3 main tasks and compare the proportion of time participants spend in each view by each task type. So when planning an itinerary, participants in both groups relied on map the most. However, in block party, 4 participants used a combination of map plus list view to complement each other. When navigating between point of interest, both participant groups use the map to get the lay of the land and followed by the route. But in Google Maps, Street View was largely used as a way to confirm that they had arrived at the destination, whereas the augmented reality view in Block Party was used to establish general directions of the next point of interest, both before departing and approaching the destination. So when pointing to point of interests, people using Google Maps use the orientation arrow on the map, whereas people using Block Party use more of the augmented reality view. So for during walking, the median number of switches between the map views were 33 for Google Maps and 13 for Block Party. People doesn't necessarily like switching views per se because it was extra interaction, but 7 out of 10 people do like the ability to easily switch between different views in Block Party. And as mentioned earlier, with Google Maps, actions such as adding annotations were usually impeded by the design of Google Maps. With Block Party, people made twice as many annotations, but none of them need to abandon their current itinerary. Also, for itinerary modification, because Google Maps doesn't support an explicit itinerary, so this was not really comparable. But 4 out of 10 participants using Block Party didn't have to modify their itinerary and make changes in the way. So for the familiarity test, we tested the route, survey, and landmark knowledge. We asked participants to draw routes between 2 locations, draw arrows from one location to another, to mark a landmark on a map, or mark where an image of a landmark belonged on the map. So overall, participants using Block Party performed better in all spatial awareness questions. Even considering only the waterfront neighborhood with which both participant groups were equally familiar, the test results were similar. So the convenience to cross-check, access complementary or additional information might have facilitated the memory of route and directions with Block Party. For future work, in addition to home buying scenario, other scenarios can also be considered. For example, tourists can have less prior knowledge and be more likely to get lost. Other combinations of views could be integrated into the current design. Also, comparison using the coordinated synchronized view in different screens versus in the single screen representation might also be interesting. The increased annotation activity in Block Party is promising, but more work is required to really understand how to best support annotation activity when exploring a neighborhood. And finally, the GPS-based wayfinding mobile apps have been found in other work to detach people from physical and social interactions. So how mobile apps can be designed to help people discover and appreciate the physical world, as well as enhance social engagement, remains a key research challenge. So we designed an app called Block Party to help people build an understanding of a new neighborhood. We compared the Block Party with Google Maps with 2 field studies. We challenge the sequential and point-to-point design assumptions that dictated or impeded view selection in Google Maps, with the design emphasis on synchronized spatial views, directory-based point of interests, and an explicit support for multi-itinerary planning. We demonstrated that Block Party can help improve the efficiency of wayfinding workflow, as well as better establish the spatial awareness of the neighborhood visited. So we thank our reviewers for their valuable feedback, and thank you all for listening.
Hi, I'm Zhou from University of Michigan School of Information. Thanks for an interesting talk. So I have a question. So say if I'm a newcomer to an area, the first thing I would like to know is where is the dangerous part of this neighborhood and which part is not. So I would like to know how Block Party address this kind of issue. Thank you.
Okay, thank you for your question. So mobile apps for neighborhood exploration could potentially include lots of information, such as the crime stats or reviews of the local stores, etc. But here, our application is designed with an emphasis on the exploration part per se. So it's more like when you're in the field and you're trying to walk around and understand the neighborhood better. So in that sense, but for sure, a more comprehensive mobile application could be developed to suit that need.
Hi, Sarah McRoberts, Group Lens Research at University of Minnesota. I really like this talk, and I was wondering if when you were working with people, if you could talk about times when maybe somebody who was in a familiar, like the waterfront area, and did they ever discover things that they hadn't realized were around them? Is there a sense of exploration for familiar places too?
So do you mean whether people are more familiar with an area, whether they also discover new places along the way? Mm-hmm. Yes, we do find even people visit the waterfront area a lot, they still discover new stores or comic stores and new antique stores in the neighborhood. Even for banks, they didn't notice that it was there before. I think one of the things that Block Party provides the ability, especially using the augmented reality view, they can establish better awareness of what are all the places of interest around them, and how far, and the survey level of familiarity. Thank you.